Hi there. Hi there. My name is Matt Fuller, co-founder and VP of product at Starburst. Today I'm going to talk about how Starburst uses CockroachDB to power Starburst Galaxy. What I'm going to first cover, though, is I'm going to cover just a little bit of background about Starburst to kind of give that context. And I'm going to talk about why we chose CockroachDB and how we use it. And at the end, I'll talk about a few kind of gotchas and so on that we need to educate our developers on as we built our product. So to start, the core of Starburst Galaxy is Trino. Trino is an open source project. It was developed by our founding team when they were at Facebook back in 2013. I started a little bit before then, so the project itself is over 10 years old. It was formerly known as Presto, if you happen to have heard that name as well. And so Trino is a fast distributed SQL query engine for big data analytics, processing data at really large scales at really fast speeds. Some of the use cases might be interactive analytics, writing SQL queries, or you might connect your BI tool like Power BI or Tableau to connect and run the analytics. And also you can do ETL type pipelines, to the data lands in S3, you need to do some transformations and land it so the data's in a more consumable state. And Trino itself runs on a clusters of machines. That's how we get the scale and performance. If you need more performance, you just add more machines, and it scales quite well from a linear fashion. And then last, it's used by hundreds of organizations over there, thousands of users, thousands of contributors. So Starburst Galaxy, we're the company behind the open source project, and Galaxy is offering Trino as a service, much like CockroachDB is offering CockroachDB in the cloud is offering that as a service. We're offering Trino as a service. So I'm going to spend a little bit of time kind of talking about high level about what Galaxy is, really to kind of set up how we're using CockroachDB with Galaxy. So first, when you use Galaxy the first time, the first thing you need to do is tell us where your data lives. And one of the unique things about Trino and Galaxy is you don't have to ingest the data into our product. You just tell us where it is, and we can query it directly there. So whether it's an S3 or MySQL and RDS or some other kind of non-relational system, Kafka or Elastic and so on, we can run SQL queries against it. So you tell us where your data lives, you give us the credentials, and then the next thing you do is once you set up the data is you create a cluster. Remember I mentioned Trino runs on a cluster of machines, and by adding more machines, you can get more performance. So we have this notion of t-shirt sizes. So you'll tell us what data you want to query, could be S3 data, and then you tell us how big you want your cluster. You also can pick the cloud and region that you want to deploy in. And then finally, you're up and running. You can do this in a matter of minutes, and you can start running queries. In this screenshot here, you can run queries through the IDE to really kind of try it out, but also you could use your favorite tool, whether it's a BI tool or a developer SQL tool and so on. We have standard JDBC, ODBC drivers, so you can just kind of connect to it like you could any other SQL database. And so the types of data that we're storing is Galaxy needs to store operational data. So whether that's the cluster information, the state of the clusters, the versions, we also have a full authentication and authorization system. So we're storing users, privileges, who can access what tables, clusters, columns, and so on. And we're storing that all within CockroachDB. So from a high level architecture perspective, we have these Trino clusters that run in a Trino plane. You can think of it as like a data plane. And we effectively have these in all cloud, all regions. We have like 50 of them. And then we have control planes that really kind of power the life cycle of these Trino clusters. And we have these geographically dispersed across different regions. We want to make sure that they're really close to the Trino plane because the interactions need to be really fast with low latency. And this is where we run CockroachDB in the control planes. So now that I've given the background of Starburst Galaxy, I want to talk about why we chose CockroachDB and the problems that it solved for us. And from the very beginning of developing Galaxy, we chose CockroachDB as the database that was going to power our application. And that was really nice because we could design our usage of CockroachDB as we built Galaxy itself. And it really solves a lot of problems for us. So the first is reliability. We need to have no downtime or data loss. If the database goes down, then our application goes down. We also need to make sure that it's always available, even if a region goes down. We have customers all across the globe, and it was really important that we can't just make sure, if one region goes down, the application goes down. So it was really important that that needed to stay up. And that's because we're supporting customers all over the world. And the other thing as well is it needed to be really low latency. We wanted to make sure that our customers in the US had no different performance behavior than our customers in Asia. So it was really important to have low latency no matter where you were using our product. The other part that was really important to us that CockroachDB helps with is development, in particular developer efficiency. CockroachDB has standard SQL semantics, so it just kind of works like Postgres, for example. And it doesn't really. It's loud over there. It doesn't require you to know things like the CAP theorem or eventual consistency or other kind of more complex concepts. You just have to. It just works just like a database. Another really cool thing is it supports things like unique indexes, constraints, foreign keys, etc. And this allows us to push a lot of the logic into the database itself. So that can effectively eliminate any kind of bugs that might be associated if you're trying to do it at the application layer. We can enforce it in the database itself. So it makes it really robust against that. And then also the serializable transactions was also a really, really big thing. Our developers don't have to worry about kind of those type of semantics. Oh, if I read some data, do some things, and write it back. What if happens if someone did something in between there, right? By using transactions, you can rely on the database, and it just really helps prevent errors. And then the last is the operations was another important thing for us. So we use the managed service for CockroachDB. We just want someone else to run it. We're enabling our customers to use Trino as a service in the cloud, and we didn't want to be in the business of having to manage a database as well, have to handle updates and backups and so on and so forth. So just letting someone else do that and our experts do it is really important for us. Another really interesting thing with CockroachDB is it allows for us to evolve as we add new features. Every time we add a new feature in Starburst Galaxy, we have to make a schema change. CockroachDB allows for kind of like an online schema change, so you don't have to take the system down while you're migrating the schema. It just stays up, and it's a lot harder if we were using a system like MySQL. It just makes it a lot more complicated. So CockroachDB solves that problem as well. And then finally, it just transparently scales to larger clusters. So we don't have to worry about manually sharding data or adding more nodes and so on. Cockroach just handles that entirely for us. So it made, these three things made, allows us to focus more on building our application, and you just don't have to worry about any of these problems that could come up if you're trying to manage the system yourself or maybe even using another system to manage your operational data. So now I talk about kind of why we chose it. I'm going to go into a little bit more how we use CockroachDB. So as I mentioned earlier, we need to use it to store operational data. So that's things like the Trino cluster management. How are these clusters deployed? What versions are they running? Do they need to be updated? Are users and permissions? Users group privileges. And in fact, when someone submits a query to us, we're doing all those permission checks per query. So it was really, really important that there's a very, very low latency to the database to do those permission checks, because we're doing the permission checks by querying CockroachDB. So it's really important that needed to be fast as well. We also use CockroachDB for the metastore for user data. So if you want to query S3, S3 is essentially files, even if they're Parquet and so on. You need to catalog it. You need to know the column names, the data types, the table names, where they're located, and so on. If you're not using Glue, for example, you can use our internal metastore, and this makes it really simple to use. And another thing that we're storing in CockroachDB is the Trino query history. So every time you run a query against Starburst Galaxy, we're saving not only that query, but the explain plan, the performance information, who ran it, the auditing information, what columns are accessed, what tables are accessed, anything that you may want to know when you're running a query, we store that. And that data itself is thousands of times larger than any other data that we're storing in CockroachDB. and it just makes it really simple. We don't have to worry about having to scale it up or so on. Just CockroachDB takes care of it for us. And the other thing we use CockroachDB for is storing transient state for our stateless services, right? So instead of having to build or manage some type of gossip system, we just use the data in CockroachDB so that these services kind of like know about each other and they can read to and from CockroachDB. The other piece here is global tables. So CockroachDB helps us how we handle kind of geo-distributed data. So they have a variety of ways to help us with this, and each has some certain trade-offs that we had to consider as we were building Starburst Galaxy. The first thing we consider was kind of a region by row, which means you can keep the customer data close to the customer. The challenge we had there is we have customers that are in different regions and in different clouds, so that means even if it's the same customer, the users for that customer in an Asia region may have a very different experience than the customers in a US region if you're doing region by row. So that just wasn't really going to work. It's really important that the user experience is the same no matter where you are. So we chose global tables, and this allows for really fast, low latency reads from anywhere. It does come with the expense of higher latency for writes, but that was okay because anytime we were writing, like changing cluster configurations and so on, it's okay if it's a couple hundred milliseconds or so on, because that's not in the critical path of like running a query, for example. And then there is some per statement latency overhead for writes if you're running to the non-primary region, but that's okay. We figured out a way to forward the writes to a primary region, and we kind of get around that. So we're always keeping latency in mind, and CockroachDB helps significantly with that. The next part I'm going to talk about is kind of schema migration. So CockroachDB helps us with all the things I mentioned and all those wonderful things that I went through. But one of the things we had to really pay attention to is schema migrations, because as we add new features to our product, we need to migrate the schema. Maybe we're changing something in the existing schema, or adding a column to the table, or adding a new table, and so on. So we use Flyway for that. Flyway is a Java schema migration tool. We chose that because it speaks SQL and we understand SQL. There are other tools out there that use a higher level language, but we really like Flyway. There was a little bit of a challenge here because Flyway was written before CockroachDB had transactions, but open source to the rescue. We were able to make the changes required to get it working. We're actually working with the teams now to upstream that to open source. It was a very nice collaboration there as well. And if you want to check it out in the interim, it's at that address before we upstream it back. And then just like a couple things, like these weren't huge issues, but there were things that we just had to make our developers aware of about kind of how the transaction interactions work. So some of the things are like, just beware of mixing DML and DDL. In this example, just pretend this is a schema migration, and it's obviously a contrived example, but in this example we're multiplying the value of x by 2, and then we're adding a not null constraint on the table. We get this error message that looks like the transaction failed. However, in the data, what actually happened was the data was actually updated, but the not null constraint failed. So you just have to be aware of these things. It wasn't a big deal, but these are just the types of things that as we onboard our developers, we just need to make sure they're aware of. Let's just skip to my last slide here. So we just kind of came up with rules for the migration. So DDL that interacts with existing data, that can fail. So we just tell our developers, avoid mixing these things. And if you do have to mix it, make sure that it's when the DDL can't fail. Only do kind of one alter table statement per transaction, and try to use separate transactions where possible, unless is absolutely required. And then always like just test everything thoroughly. But again, this really wasn't a big deal. It's just things we have to educate our developers on about how the transactions work in the system. And thank you for coming to the talk. I hope you enjoyed it. CockroachDB has been wonderful for as we've been developing Starburst Galaxy, and really has helped solve a lot of the challenges that we would have had if we didn't have it. Thank you.